And over here, then I have the square root of 10x minus 25. And you might see some other things. Maybe you'll see like x plus 2, or that's fine as long as the square root is isolated. Okay. Your other option is if you wanted to move the x from both sides, you could, and then divide by -1. That's fine. Now I can square this expression, but remember this is an equation. So what do I have to do? Square this side, square this side. Okay. Now what does this look like? Quadratic, right? So really, solving this is no different than what we did in the opener today, but I just wanted to give you some tools about how you remove that square root when you see it today. So let's go ahead and solve this one. I'm going to move this stuff back to the other side, or if you want, you can move the x squared to the right side. Be careful when I do that. If I moved this 10x to this side, what would it become? Minus 10x, and then minus 25 to the other side, plus 25 equals 0. So what are my options now? You could use quadratic formula like we did in the opener. I don't know if anybody, I didn't see anybody in the opener do this. Couldn't you factor this? Yeah. Yeah, I'm going to factor it, just so we see that. But you could use quadratic formula. What does this factor into? X minus 5 times x minus 5. Or what's another way of writing that? Yeah. Okay. So then I asked myself, what would make these two parentheses, or this one parentheses, equal to 0 when x equals what? Okay. So that's our solution. Just real quickly, I'm going to graph this original expression. Once we squared it, we got this quadratic. That's like a parabola. But if I graphed the original expression, let's see what that looks like. Okay. So do you see, you can see it right there. I'm going to maybe... By the way, why doesn't it, do you see there's no y there when I'm tracing it? Does anybody know why not? The graph doesn't exist over here yet because these inputs would produce a negative, yeah, a negative value. So, alright, so anyhow, you can see if I would zoom in a little bit here. And then if I found the 0, number 2. Now this is an instance where, you know, our calculator is rounding it because it's not always exact, but if you see 4.999999979, you can assume it's exactly 5. Does that make sense? Okay. Then one other thing that we're going to show on the calculator, so if you have your calculator, take it out. If you don't, then you should share. I do have one left up there. Is something I like to call hidden behavior. hidden behavior is we're going to look at the graph, and to the eye when we have it on a window, it's not going to look, well, we're not going to be able to tell, I guess, how many solutions it has. So I'm going to just show you some tools on your calculator when you're graphing, how you can go about adjusting the window. So we're going to solve this graphically. So x cubed minus 1.1 x squared minus 65.4 x plus 229.5 equals 0. Okay? And I would not ask you to solve this by hand. We're going to solve this graphically. So very carefully, let's put it into our y equals. I'm going to go back to a standard viewing window, which is Zoom 6. Okay. First of all, this is a cubing function. From last year, can you draw in the air for me just kind of what a cubing function looks like? Yeah. Like maybe something like this or something like this, right? Okay. So in our head, this we know, okay, it's an x cubed. The real graph looks something like this or something like this. So what I'm seeing here is not a great picture of the whole thing, but what's going on is it's going up, up there it reaches some kind of maximum, coming down and coming up. So my question for you is, how many zeros or x-intercepts do you think this has?
What?
How many zeros or x-intercepts do you think this has? You think 3, you think 2, 2, okay.
5.
So why did you say maybe 3?
Well, x cubed, but I remember last year this is 3.
No, I like that. X cubed means possibly there are 3 x-intercepts. But that would be the maximum there could be, okay? It could include imaginary or those double roots where it bounces. Remember the bouncing thing? And where that counts as like 2. So here's what I'm thinking. This is clearly an x-intercept, right? Now what's going on here? Maybe it bounces and comes back up. But what if it didn't quite get there, can I tell? So it's possible it doesn't touch there at all. And it's also possible it gets below a little bit. So what we are going to do, that's the hidden behavior part. We're going to zoom in around that root to see, okay? So first question, Luigi, are you okay?
Yeah.
Okay. Let's find this one a second, just because I asked you to find the zeros. So I go to the 0, I trace over here. You've done this before, some of you. Okay. I'm watching. Okay, so it's hard to see. Switches to positive. Looks like one of the solutions is x equals -9.
There is no way. Don't touch the line.
You think it doesn't touch it?
Yeah.
Okay, let's find out. I'm going to try to zoom in over here. So my Y's are starting to come back down. I'm just watching that. Alright, I see my cursor here now, so at least I'm in kind of the right spot. and it's going down, all right, I'm going to just put it down there, and I'm going to use the zoom in function around there, okay? So I'm going to zoom in and see if I can, still can't tell, huh? Let's see if I can get a little closer. It does look somewhere like it's around 5, if it does. Ooh. Oh, it tells. Let's zoom in a second again. But in order to find them on our calculator, we have to have a window that allows us to kind of move. Now, is that a little bit better? So actually, there are 2 roots there, aren't there? Okay. So I'm going to just one more time, I'm going to zoom in, and then I'm going to find, so I have some space, I'm going to find those zeros, okay? So let's do that. And what happens is they're just very close together. So one of them is exactly 5. And exactly 5.1. Okay.